Hey, South Carolina's Math and History, and we are going to look at the division of sectors. But wait a minute, that was our last video. If we are talking about the division of sectors, and explains how you can have a midpoint that makes two congruent angles, or a segment bisector that can do all that. Well, why can't we have even more of that? So in this video, we're going to talk about the segment trisectors, not the segment bisectors. And we're also going to learn about angle trisectors, not angle bisectors. So you probably will understand what this video is before I even show it, because it has almost the exact same function, because a segment trisector is 2 points, lines, segments, or rays that divide a segment into 3 congruent segments. So, unlike the bisectors, the scenario is a segment trisector happens when you have BC can be a segment trisector. And it also means that they are all going to be congruent. So what we can say here is that AB as a segment can be congruent to BC as a segment, which is congruent to CD as a segment. So it's saying right here that BC is a segment trisector. And when you have that happen, you can have all the lines or all the segments or whatever you call it into 3 congruent segments. Let's look at a problem together. So here is our problem. You can only assume and understand segment trisectors if it was given to you in your problem or your math worksheet. So line M and M are segment trisectors. And the thing is, here is line M and line M. What we have to find out are what 3 segments could be congruent. Well, we can see that line Q is basically horizontally touching line M and line M. Therefore, we can say that even though M and N are segments and they're trisecting line Q, it also means that there's point S right here and point T. And since it was given to us in the problem, we can directly say that we have QS as a segment, ST as a segment, and TR as a segment. And what we can conclude about that is, since the problem states that you can have 3 congruent segments, therefore this, that, and that can be congruent. So segment QS can be congruent to segment ST, that can be congruent to segment TR. So that is all about segment trisectors, but we're not done yet. What happens is we only learned about the segment trisectors. Now we have to learn about the angle trisectors. So about the angle trisectors, they were just like angle bisectors in the last video. However, we have 2 rays that divide an angle into 3 congruent angles again. That triacts the angle, so it can explain that EHJ is an angle, JHA is an angle, and AHG is an angle. If they're all congruent angles, this, and that, we can explain that angle EHA EHJ, can be congruent to angle JHA, can be congruent with AHG. So it works just like the last one, but instead you're talking about angles. So when you are given to the problem that an angle trisector is this in your problem, then you can understand that you can have congruent angles within an angle. 3 congruent angles. So let's look at a problem. So this is a problem. If line D and line E is segment trisectors, or segment D or segment E is a segment trisector, then what can we conclude? Well, here's 1, and here's 2, and here's 3. The thing is, they can all be congruent. We can say that ABD as an angle, DBE as an angle, and EBC, yep, I can fit that. We can say that all the angles can be congruent with each other. So a lot about these segment bisectors, or a lot about these segment trisectors, is all about like, okay, segments that are congruent, angles that are congruent, segments with 2 and segments with 3. But if you try to look into Tau Pingerlife's math industry like right now, there's not going to be another video about quadruple trisector. No, there's not going to be another video of like segment quadruple. So it's rarely to see instead of 3, we have 4. And that concludes the video. I hope this video has helped you understand about segment trisectors and angle trisectors. Thank you for watching Tau Pingerlife's math history. Like and subscribe!